Okay, in the colligative properties one here, we had to show the graph. So the graph is going 20 down to 10, and it levels off at the freezing point and then goes down to 0. In the other curve, the solution, it's got to be lower than 10, and the real curve is slightly slanted, but you would have gotten points if you had drawn a flat line that's just plateaus lower than 10. Okay, so then it says the information from this graph can be used to determine the molar mass. So you need to know the freezing point depression equation, and what you need to know is we won't know the molality because we don't know how many moles of particles that we put in there, but we will need to know how many grams of solute that we put in there and how many kilograms of solvent, or we could know how much the total solution, how many kilograms the total solution weighs, and one of these two. Okay, so as long as you know two of those three things, you'll be able to get what information you need about the moles. The other thing you have to have is the change in temperature. Okay, and then what we need to do is show the setup for the calculations that must be performed to determine the molar mass. So once we know this and we know this, so you'll have to solve delta T equals KFM with that I. Solve for M. The I here is it's called the Van Hoff factor. That depends on how many particles. So like NaCl would have 2 because it breaks into 2 particles. In this case, it doesn't really matter because we're going to know how many moles that we have. And it also says that it's a non-electrolyte, which means that it's not going to break into ions. So we can know that I there is 1. So we'll solve that equation for M. And then we will, once we have M, we can multiply by the moles per gram solvent, multiply by gram solvent to give you just moles, and then gram solute divided by moles is molar mass. Sorry. Explain how the difference between the two graphs can be used to obtain the information needed. So we have to show that the plateaus, the difference in the temperature can be found, the freezing point depression can be found from the plateaus. I guess we would say by subtracting temperatures of plateaus. Okay, suppose that during the experiment a significant but unknown amount of solvent evaporates. That's going to make our solution has the molality, which is the moles solute divided by the gram solvent. So if we now have a smaller number here than what we thought we were, we're going to have greater moles than what we thought we would have. And molar mass is grams divided by moles, so we should have a smaller molar mass. Okay, it says if some of the solvent evaporates, then this molality term is going to be bigger than what it would be, and so the molar mass would be smaller. Okay, show the setup for the calculation of percent error, so that's pretty easy. It's measured minus actual over actual. So measured was 126 minus actual over actual times 100. And you just need to show the setup there.